Alright, so let's start. So 4.2, solving linear inequalities. So if you add or subtract a constant to both sides, the direction of the inequality sign is maintained, whereas multiplying or dividing both sides by a negative constant causes the sign to switch direction. So what do we mean with that? Let's say you have x plus 3 greater than 5, okay? When you're isolating x, you can subtract 3 from both sides, right? If that is the case, you know, that you're adding or subtracting the same number to both sides, the direction of the inequality is not going to change. So you get x greater than 2, okay? However, let's give a second, or let me put this here. Okay, so let's say we have another case, negative 2x greater than 6. Okay, now to be able to isolate x, you need to divide both sides by negative 2. Okay, because you're dividing by negative number, so then you change the direction of the inequality sign. So 6 divided by negative 2 is negative 3. Okay? This happens only when you are dividing or multiplying both sides by a negative number. Alright, so now representing solutions. Okay? Let's say you have a solution set x greater than negative 2 and less than 5. So using the set notation, we already looked at it before, you can represent it as x greater than negative 2 less than or equal to 5. So using the interval notation, right? So from negative 2 to 5, negative 2 is not included, you see a hole, and 5 is included because this point is colored. So you have a square bracket here for the covered point. Alright, example 1. So each inequality, verify your results graphically. Okay, first we are going to solve it algebraically. So we have 3x minus 8 greater than or equal to 1. We are trying to isolate x here. Okay, so you can think for now like an equal sign, but you need to be very careful when you're dividing or multiplying both sides by a negative number, because then the direction is going to change. Okay, so for now I'm going to take negative 8, move it to the other side, or you may think, add 8 to both sides. So that will give you the same results. So you get 9 on the right. Now we divide both sides by 3. Okay, so you get x, so 9 over 3 is 3, greater than or equal to 3. The direction of the inequality did not change because we divided by a positive number, not by a negative number. So if you wanted to represent this solution with interval notation, then you would say 3 to positive infinity, 3 is included and infinity cannot be included, so it's a round bracket. Now we're going to verify this result by graphically. Okay, this is how we do it. Look at the original given inequality. Okay, use the inequality sign, okay, and look at the left side and right side. On the left we see 3x minus 8, on the right we see 1. Okay, so now we are going to graph 3x minus 8, y equals 3x minus 8. Also we are going to graph y equals 1. Okay, and then see what will happen. Okay, so y equals 3x minus 8. Negative 8 is the y-intercept and slope is 3. So 1 right, 1, 2, 3. 1 right, rise 3. 1, 2, 3. Okay, so follow the pattern. So sketch the line. So this is y equals 3x minus 8 line. Now sketch y equals 1 line, right? On the right we see 1, therefore we are going to sketch y equals 1 line. After you have graphed both of them, now again look at the original. What does it say? We want 3x minus 8 greater than or equal to 1. So this is what we're going to do. We're going to find the intersection points of those two lines, draw a vertical line from there. Okay, so using that line, so we kind of divided the whole grid in two pieces. Okay, now we're going to check the left side and right side and decide which one works for us. Okay, so when you look at the left side, we see that y equals 1 line is above 3x minus 8 line, right? Y equals 1 line is above the 3x minus 8 line. So that means y equals 1 or 1 is greater than 3x minus 8, or 3x minus 8 is less than 1, right? So for this section, okay, on the left side, we see that 3x minus 8 is less than 1, correct? It is below 1. But when you look at the right side, what do we see? We see, so this oblique line is greater than that above that horizontal line, right? So that is telling you that 3x minus 8 is greater than 1, or the y values of 3x of minus 8 greater than 1. So the right side, 3x minus 8 greater than 1, because the line is above y equals 1 line. So what do we need? We need 3x minus 8 greater than or equal to 1. Now we need to check the x values for this part. So look at the x values, look at the x axis. So what do we see? We see that all x values greater than 3. Okay, we are checking the x values for that part, x greater than 3. But since we need greater than or equal to, then the solution for this part is x greater than or equal to 3. So this is exactly matching with what we got algebraically. Any question? Is it okay? So let's look at the next one then. Again, first let's solve it algebraically. So we are going to isolate x again. Okay, so let's move negative 4 to the right, or you can add 4 to both sides, doesn't matter. So when you move this to the right, so you get 10. Now divide both sides by negative 2. So 10 divided by negative 2 is negative 5. But because we are dividing by a negative number, now the direction of the inequality will change. Now it's going to be this way. Okay, so this means x greater than negative 5. So you can also write this using the interval notation. So negative 5 to positive infinity. Now we are going to verify this again graphically. So look at the original question. So we are going to sketch y equals negative 2x minus 4. We are also going to sketch y equals 6. Okay, so let's sketch y equals negative 2x minus 4. So minus 4 is the y-intercept. So slope is negative 2. 1 right, 2 down. 1 right, 2 down. Alright, so this is y equals negative 2x minus 4. Now sketch y equals 6. After that, we are gonna apply the same rule. Okay, so find the intersection point, draw a vertical line through it, this is gonna help you to decide. So now we divided the grid in two pieces. We are gonna check the left side and the right side. Okay, so left side is here, right side is here. Okay, left side, what do we see? We see negative 2x minus 4 line above y equals 6 line. Is it correct? The y values of negative 2x minus 4 is greater than 6. So then on the left, negative 2x minus 4 is greater than 6. What do we see on the right? We see that negative 2x minus 4 is now below y equals 6 line. So it means that the y values of negative 2x minus 4 is less than 6. So therefore the right side, negative 2x minus 4 is less than 6. What do we need? We need negative 2x minus 4 or negative 4 minus 2x, doesn't matter, less than 6. So we want this right side. We want the x values for that right side. So let's look at the x values, right? So how can you represent those x values? So there's negative 5, x greater than negative 5. So same as, the algebraic work. X greater than negative 5. Any question? No? Okay. Example 2, solve each inequality. Okay. So as you see now, we have x on both sides and we have number on both sides. So what are we going to do? First, if you see a fraction, get rid of it right away. Okay. So we see 2 in the denominator. So we can multiply both sides by 2 to get rid of it. So multiply both sides by 2. So we have 4x minus 3, 6x minus 10. Okay, so next collect x values on one side and numbers on the other side. Okay, so 4x minus 6x, negative 10 plus 3. Of course, when you are switching sides, make sure you change their sign. So we end up with negative 2x less than or equal to negative 7. Now divide both sides by negative 2. So negative 7 divided by negative 2 gives you positive 7 over 2. But because we are dividing by a negative number, you switch the sign, the direction of the sign. Well, if you collected x's on the right side, you would end up with a positive coefficient for x. Then when you divide it by that positive coefficient, then you didn't have to change the direction. But doesn't matter, right, at the end. Okay, so what do we have here? X greater than or equal to 7 over 2. So from 7 over 2 to positive infinity. So when you are using the interval notation, you always put the small number first and then greater number. Okay, so 7 over 2 is included, so square bracket. So infinity is not included, so a round bracket. Next one, again we see a fraction on both sides. Okay, so one denominator is 3, the other one is 2. So you find kind of a common denominator. So you multiply both sides by that, right? 6. So you multiply both sides by 6. What do you get? 2 times x minus 2 greater than 3 times 4x minus 1. Now get rid of the brackets. So we are okay with this, right? 6 divided by 3 gives you 2. You multiply 2x minus 2 by 2. 6 divided by 2 gives you 3. So 3 times 4x minus 1. So now get rid of the brackets. 4x minus, so 2x minus 4. 12x minus 3. Now I'm going to move x to the right. So you get 12x minus 2x. 3 to the left. You could do the opposite, right? So you get 10x less than negative 1. Divide both sides by 10. So you get x less than negative 1 over 10. So if you want to use the interval notation, so x less than negative 1 over 10, so it goes to negative infinity. So from negative infinity to negative 1 over 10. And negative 1 over 10 is not included, so you use round bracket here. Yes?
Why is it from negative 10 to negative 1?
Because x is less than negative 1 over 10. Yeah? So means that, you know, any number less than negative 1 over 10, so it goes up to a negative infinity. But we always use the smaller number first when you're writing the interval notation. Okay? Moving on. Okay, example 3. So now what is the difference here? You see two inequality sign. Okay? So how are we going to do that? So again, our purpose is isolating x. Okay? So we see negative 4x plus 8 in the middle. So first we are going to get rid of that 8. Okay? So you can, but we cannot just move it like there is 1, right? Because there is 2, we cannot do it. Therefore, that's what we're going to do. So to get rid of 8, I need to subtract 8. So I'm going to subtract 8 from all 3 parts of this. Okay? So you get 20 minus 8, negative 4x plus 8 minus 8, 40 minus 8. Okay? Then you get 12, negative 4x, 32. Now we can, you know, so x is multiplied by negative 4. So we can divide all parts by negative 4. Okay? So negative 4x divided by negative 4, x obviously. Okay. So 12 divided by negative 4, negative 3. 32 divided by negative 4, negative 8. But because we are dividing by a negative number, now the direction of the inequalities will change. Okay? So this one and that one. So x is greater than negative 8, but less than or equal to negative 3. So if you want to use the interval notation, so negative 8, negative 8 to negative 3. Okay, negative 3 is included, negative 8 is not included. Example 4. Again solve. Again we have double inequality sign. Okay. Purpose isolating x. Okay. So you can do it 2 ways. One, you can expand this bracket, multiply, you know, x by negative 4 and 6 by negative 4 and then isolate. Or you can directly divide everything by negative 4 first and then solve. Okay, let's do that one. So we are going to divide everything by negative 4. So 20 divided by negative 4, negative 5. So in the middle we have x plus 6. 32 divided by negative 4, you get negative 8. Okay, now because we divided by negative number, again the directions will change. Okay, next step, we need to get rid of that plus 6. So subtract 6 from all 3 parts. Okay. Then we get negative 11 x and negative 14. So x greater than or equal to negative 14, less than or equal to negative 11. Again, if you use interval notation, so you get negative 14 to negative 11, and both sides are included. So next one is a little bit different again, because see, you see the variable, you have double inequality sign, but you also see x in all 3 parts. Okay, so that is different than here. So how are we going to do it? So to get rid of x here, okay, so we are going to subtract x from all parts first, because we want x to be only in one place, in the middle. In this case, if you have two, so double inequality sign, okay, we want x to be in the middle. So therefore we need to get rid of all the other x's. Okay, so now we can subtract x from all 3 places. So we end up with negative 3 on the left, 3x minus 6 in the middle, and 10 on the right. Now we want to get rid of that negative 6, right? So now we have only x in the only in the middle, right? But now we want to isolate that, so we can add 6 to all 3 parts. Okay, so we get 3, 3x, and 16. Now finally divide all 3 parts by 3. So this gives you 1 x and 16 over 3. So x greater than or equal to 1 and less than 16 over 3, represented with interval notation 1 to 16 over 3. 1 is included with a square bracket and 16 over 3 is not included. For now, there is another way of solving this kind of inequality. Okay, you know, so this is how you do it. I'm not gonna show it in details, but you do this. You take these 2 on the left and solve it. Then you take these 2 on the right and solve it, and then you find intersection intervals for both solution, and that would be the solution of the whole thing. But for now, you know, you don't need to go over, because see, this, the way I showed you, is going to work only if x on the very right and very left have the same coefficient. Because if you subtract x, the x on the left and right will disappear. Okay, it can be 2x and 2x or 3x and 3x, right? So then it will disappear. But if you have x here and then 5x there, if you subtract x from all 3 places, we are still not going to get, you know, like x only in the middle. So that's not gonna work. But in the book, homework questions has only this type. So, you know, the variable on the left and on the right has this, they have the same coefficients. So you will be fine with this method of solving for now. Example 6. Determine if 2 is a number in the solution set of the following inequalities. So you can do it, this question 2 ways. 1, you can solve it and check if 2 is in the solution set. Okay. Number 2 is easier. So you can directly substitute 2 and see if it makes this inequality, or if it satisfies this inequality. Let's use the shorter method here. Okay, so you substitute 2 in here, so 8 11 and you get 20 here. So check if this is true. So 11 is less than 20 and greater than or equal to 8. So looks like this works, right? Okay, let's check the second one. So now we are substituting 2 here. We get 7 and then 0 on the right. So 0 greater than 7. Is this okay? Can 0 be greater than 7? No, right? This is not okay. So then 2 does not satisfy this inequality. Means 2 is not in the solution set of this inequality. Okay? Let's look at the next one. Example 7. Which of the following inequalities has a solution? Okay, let's solve. So we see 2x on the left, on the right. So we want only in the middle, right? Then we are going to subtract 2x from all three places. So we get negative 9 on the left, 3 minus 3x in the middle, and negative 6 on the right. Okay, now we need to get rid of that 3. Okay, so then we are going to subtract 3 from all three parts. Minus 3, minus 3, and minus 3. So we get negative 12, negative 3x, and negative 9 on here. So now we want to isolate x, divide all three parts by negative 3. So you get 4x and 3. But because you are dividing by negative 3, okay, so the direction of the inequalities will change. So is this okay? Can x be greater than 3 and less than 4? Yes, right, let's say 3.5. So yeah, this has a solution. So when you look at part B, actually the numbers are exactly the same. Can you see? Like all the numbers are exactly the same. So you can solve it the same way, but the only difference is the direction of the inequalities. See? These two are looking to right and these two are looking to left. Okay, so only the direction of the inequalities change. So you are gonna solve it exactly the same as part A, alright? But let's say you are here, okay, I'm just gonna start from here because it is exactly the same solution. But you will get this because the direction, okay, of the inequalities the opposite way. Instead of having this, you're going to have that. Okay, so when you divide both all three sides by negative 3, that's what you end up with. Let's check if this is possible, right? X greater than 4, less than 3. Is it possible? Can you find a number that is greater than 4 but less than 3? No, right? So therefore this one does not have a solution. Therefore when you are solving inequalities, so you look at the last final result if it makes sense or not, right? Okay, last two examples. So we are given g of x and f of x. Okay, so there are arrows at the ends. Find the equation of these lines. So let's do that. So we have f of x. So that's the line. So you find the y-intercept 3 and you check the slope. So looks like 1 right, 1 up. So slope is positive 1. So we get x plus 3. So now let's look at the equation of g of x. So looks like the y-intercept is -1, okay? And now check the slope. So first of all, it is falling to right. So you know that the slope is going to be negative, okay? Now, maybe you can do this, right? So 1 right, 1, 2, 3 down. So -3x minus 1 is the equation of g of x. Now it says solve for f of x greater than g of x by examining the graph. Okay, so what we were doing, we are going to do exactly the same thing. First, so you have two lines. First, find the intersection point, draw a vertical line through that intersection point. Then we divided this grid in two pieces. Okay, so we have the left side and the right side. So for the left side, what do we see? So this is g of x and this is f of x. Which one is above the other line? So we see that g of x is above f of x line, correct? Then you say g of x is greater than f of x on the left. Okay, so now check the right side. So this is f of x and this is g of x. Okay, so this time f of x is above g of x, right? So f of x is greater than g of x. F of x greater than g of x. Okay, or you can say g of x is less than f of x. It is the same thing, right? Okay, what are we looking for? We are looking for where f of x greater than g of x. So f of x greater than g of x on the right side of this vertical line. So how can we write the solution? Again, we are looking at the x values when you are writing the solution. Only the x values, okay? So now all these x values we need. So greater than -1. So x greater than -1. Confirm your answer by solving the inequality. Okay, so we want f of x greater than g of x. Let's write their equations. So x, we want x plus 3 to be greater than 3x minus 1. Okay, so I'm gonna move -3x to left, move 3 to right. Oops, just put the final result. Okay, so we get 4x greater than -4. Divide both sides by 4, you get x greater than -1. So we got exactly the same thing with the graph. Okay, examining the graph. Last example. Solve the following inequality. Verify your results graphically. Okay, so first we're going to solve. So we need to get rid of -2. Add 2 to all three places. When you add 2, you get -2, 2x, and 8. Now x is multiplied by 2. You divide everything by 2. So you get -1 and 4. Okay, so with interval notation, -1 to 4, both sides are round brackets. Now it says verify your result graphically. Until now we did the solutions graphically, but we had only two parts, right? And we had only one inequality sign. But this time we have two inequality signs and we have three parts. 1, 2, 3. Therefore we are going to sketch three graphs. Okay, so one is y equals -4. The other one is the oblique line, 2x minus 2. So minus 2 is the y-intercept, slope is 2, so 1 right, 2 up, 1 right, 2 up, 1 right, 2 up. Okay. Now the third line is going to be y equals 6 line. So now we don't have only one intersection point but two. So draw vertical lines through those intersection points. Now we separated the whole thing in three pieces. Okay, there is there is one side on the left, there is the middle one using the vertical lines, and then there is the right side here. Okay, so now when you look at the left side, what do you see? We see that this oblique line, which is 2x minus 2, is less than 6, less than 4, right? Because see, this oblique line is below y equals x 6 line and below y equals negative 4 line. So this means that 2x minus 2 is less than negative 4 and less than 6. But that's not what we want, right? We want less than 6 but greater than negative 4. Now we're going to check the middle. Okay, now this again oblique line here is 2x minus 2. Okay, so that oblique line is below 6, y equals 6 line. It is below that, but it is above negative 4. So that's exactly what we need, right? So looks like we are going to take the middle part here. If you looked at on the right, what would you see? This oblique line is greater than negative 4 but also greater than 6. It's above both lines, so we don't need that one, right? Again, we need this part. So where 2x minus 2 is greater than negative 4 and less than 6, so that is from negative 1 to, we are looking again the x values for this interval, right? So that gives you negative 1 to 4, and both sides are, you know, there is no equal signs, so negative 1 and 4 is not included. So you get exactly the same results. Related homework is written here.